Professor Forbes, for your insightful and thought-provoking talk. Uh, we deeply appreciate your time and your expertise and your generosity in sharing this work with us today. We have a few questions from the audience. So coming to the first question, they have asked, given that your analysis employs thermal desorption using the Gerstel TDS3 system, so what measures do you take to minimize or prevent thermal degradation of thermally labile compounds during the desorption and transfer steps prior to their introduction to the 2D GCMS?
Okay, so obviously the range of analytes which you can measure does vary depending on the temperature. You also have to change that depending on the analytes you're interested in. The process also for desorption is very fast. So that time at which the analytes are exposed to the high temperatures is extremely short because there's ballistic heating to transfer those analytes in a very small plug onto a cold trap, which focuses them prior to the heating thereof so that they can move into the GC. But yes, if there is a compound that is particularly labile and is of concern, it might be necessary to do some derivatization, for example. That is one means around that. So you would have to check your recoveries using standards to make sure that the method is valid.
Thank you, Professor Forbes. We have another question related to the 2D GCMS. So why is multi-dimensional gas chromatography is preferred over the conventional analytical methods for identifying organic air pollutants?
Yes, so as I showed in a number of the slides, the issue is that with one-dimensional GCMS, you can get overlap. And so you might think that you're seeing one peak, but actually there's more than one compound present underneath it. And so the 2 dimensions allow us to pull those apart, to separate them and basically deconvolute them. There's also very advanced software that allows for data processing and deconvolution of overlapping peaks so that we get better what we call peak purity. And we can be sure then that what we are determining is in fact what we think it is. And it's not that we have an enhanced signal because of overlap of peaks or that we cannot identify the actual compound, because it is a mixture of ions and therefore the mass spectrum won't actually correspond to what it is in the NIST library because it's a mixture.
Thank you, Professor Forbes. We have another question on when using PDMS-based sorbent traps for air sampling, particularly for chlorinated polyaromatic compounds, how reliable is the reproducibility of the analytical results?
Yeah, so the issue comes in when the mass spectra are very similar for different homologies. It can be difficult then to be able to be sure that you are identifying the compound correctly. So in all cases, in order to be sure when you are quantifying, you need to have the authentic standard, the native standard, that you analyze and under your same conditions. So you then determine what the first and second retention times are, as well as the mass spectrum, so that you can then be sure that you are actually identifying the compound correctly. With some of the chlorinated compounds, they use the chlorine atoms very readily. And so analysis can be more tricky, and you have to then make sure that you have the correct standards to make sure that you are identifying them correctly.
Thank you, Professor Forbes. They have a follow-up question on that. Considering that Delhi's atmosphere presents high humidity levels alongside chlorinated polyaromatics, which can accelerate PDMS degradation, what strategies or alternative approaches would you recommend to mitigate these issues and ensure stable, reproducible measurements?
Yes, so of course we don't want any moisture getting into our GC. Fortunately, PDMS is hydrophobic, so that does help us in that it doesn't actually absorb the moisture. Under high humidity conditions, it might be necessary to actually allow the trap to dry out before putting it into the thermal desorber, although in the applications that we've used it in, we haven't had such problems. But under high humidity conditions, you would need to make sure that it was dried, because otherwise you're going to have issues with ice buildup as well in the CIS. So that would be a problem.
Thank you, Professor Forbes. Do you have any air quality monitoring data from areas surrounding a plastic incineration facility in South Africa?
No, so not directly, I don't. But one of my postgraduate students is currently doing his PhD. That's Reinhard Kromhout, and he is the laboratory manager of a commercial laboratory here in Pretoria. And I know that he has done some studies for industry, or he's done some analyses for industry on such emissions. And we developed a method for dioxin analysis as part of his PhD that he's now employed at his laboratory. And that is actually the first laboratory in South Africa that can do these dioxin analyses, for example. Previously, those samples were all sent overseas for analysis.
Thank you. Another question on pHs. So they are semi-volatile organic compounds which can accumulate in the soil, sediments, food chains. So what are the effective methods or technologies available for their removal and environmental remediation?
So this is something that's interesting because I always complain when people call them persistent organic pollutants because they're not actually listed in the Stockholm Convention. So we cannot actually say that. But we do know that a number of them are persistent in nature. Some of them are degraded by certain bacteria in soil and so on over time. But in many cases, incineration is required to actually break down the more recalcitrant pHs. The thing we need to always remember, though, is that pHs are naturally occurring as well from natural processes. And, I mentioned the scope of Earth and space chemistry, and we find them in space as well. So they are fundamental molecules in our environment and in our solar system. Yeah, we need to acknowledge them as such. But yeah, some of them are persistent, others are more readily degraded.
Thank you, Professor Forbes. We have another question where what are the major challenges that arise in monitoring semi-volatile organic compounds in complex environments such as like underground mines?
Yeah, so we went down more than 1 kilometer underground. So at those depths, it becomes very hot. It's not very easy to work. You have to carry all your equipment with you. So it was very useful that we had these small pumps and that the denuders are small and lightweight as well. So I'd say, yeah, the logistics and the conditions, the physical conditions are actually the most challenging in terms of taking the sample.
Thank you, Professor Forbes. And how do you account for the potential interactions between aromatic molecules after desorption, but before they enter the GC columns, particularly as they pass through the PDMS capillaries, where temperature fluctuations may influence these interactions?
So our temperature is stable during analysis. During sampling. We then end cap the traps, glass on glass, to make sure that we don't have any loss in that regard. And we wrap them in aluminium foil to prevent any photo degradation. We then keep them under cold conditions in a cooler box until reaching the laboratory where we keep them cold as well in the refrigerator prior to analysis. So in that way, we protect the integrity of the sample. And once we insert it into the thermal desorber, it's a very rapid process for the desorption prior to analysis.
Thank you, Professor Forbes. Could you clarify how interfering particles affect the analytical outcomes?
So I'm not sure which interfering compounds specifically. So if it's coelution and interference in that way, I think that I already addressed in using the two-dimensional chromatography. In terms of the monitoring, so the PDMS is not suitable for sampling very small molecules because they don't partition effectively into the sorbent. They break through, they pass straight through. So in that way, we do have a reduction in terms of potential interferences from smaller molecules, which otherwise, if they had been retained, they could potentially react with our analytes of interest, like SO2, for example.
Thank you, Professor Forbes. So we have one general question. If we were thinking of designing a comprehensive air monitoring program for a developing region, what key elements would you include?
Well, I think we have to start with the priority air pollutants. So things like CO, CO2, NOx, SO2, particulate matter, and of course the different size fractions, particularly PM 2.5 for a health point of view. So those are the standard ones that are used, globally. Ozone is also of interest and concern in terms of the potential impacts that it can incur both on materials as well as on people. But depending then also on how much funding is available, I think it is important to do more comprehensive analyses and monitoring, such as the analysis of PAHs in regions where there's not electrification and where there's a lot of coal and wood use, so that we can better ascertain human health impacts and then look at alternatives to try and improve the quality of life in those communities. So that would also be more targeted monitoring, not regular routine, continuous everywhere, but really to target particular issues. Of course, it depends also on the particular environment. There was a question earlier about the plastic waste burning. Waste burning is definitely an issue in developing countries. It's a project we're currently working on with one of our industry partners, because in some areas service delivery is poor, and so people burn the waste because they need to make sure that it's removed so they don't have rodents and pests causing problems in their residences. But we know that burning waste is generating a lot of hazardous air pollutants, and this is something that we are currently looking at better understanding so that we can inform policy and try and leverage government to improve service delivery and therefore assist with the air quality in these areas.
Thank you, Professor Forbes. Could you elaborate on the thermodynamic and kinetic considerations underlying your method, as well as its reproducibility and the future prospects for improving compound recovery?
Okay, so maybe I'll start with the end of it, the compound recovery. So with that, we know that there's a certain range in terms of volatility that we can realistically thermally desorb based on the upper limits at which we can heat the PDMS2 until it becomes brittle and degrades. And so there is an upper limit, and we know that for the heavier PAHs, they are harder then to desorb. So we bear that in mind in terms of how we interpret our results. On the other side, in terms of volatility, the very volatile organic compounds, as I mentioned, would not be suitably retained. So, we have the semi-volatiles are what we target because those are the ones that we know we can effectively desorb. What was the first part of the question again?
On the thermodynamics and kinetic considerations.
Yeah, so that comes in terms of the partitioning, because of course I showed on one of the early slides an equation that showed what is actually driving the partitioning, which depends on the particulate matter concentration, but as well as the temperature. So it's important to make sure that you do sample at a constant temperature, so that and then retain your samples in a manner that do not allow any later evolution volatilization of compounds, for example, from the particulate matter, from the filters, to ensure that we maintain sample integrity, because it is driven by temperature, that partitioning process.
Thank you, Professor Forbes. Could you elaborate on the cost implications of producing alternative diesel compared with the recycling processes and the development of technologies for capturing greenhouse gases? How do and it's a follow-up question on that, like how approaches differ in terms of overall economic impact?
Okay, so we didn't actually make the fuel, we bought it, but in the project, the bigger picture, which I didn't have time to really go into, was to consider the sugarcane burning, which is currently done, as I mentioned, prior to harvest. And we did some work looking at the emissions on that to say, now, instead of burning that material, if we could actually utilize it as an energy source to actually generate some fuel products, that could then potentially be used in applications such as the underground mine. And for the mining environment, we know that they have surface, ground surface that is available to potentially grow crops that could be used to generate biodiesel and create more of a circular economy. So that was the bigger consideration for that project. The actual further studies, and we did look into the economics of that to some degree, but the further investigation into that was outside the ambient of that particular project. Having said that, in developing countries, we also have to, of course, be very careful in terms of which biodiesel we look at and which fuel source we use for it, because we don't want to utilize material that could be used as food for the biodiesel production. Recycling is something that has been given some thought to. Our industry partners, Sasol, have done a lot of work also looking at utilizing recycled and reclaimed oil in engines. But the issue we have is the vast variability in quality. And that leads to a lot of engineering issues and maintenance issues with the engines. And also, as a consequence, can lead to great fluctuations in terms of the emissions that result. So it's challenging to use such products, particularly, I think, in developing countries.
Thank you, Professor Forbes. Is it possible to investigate pH source apportionment in case of highly variable pollution load scenarios, especially in the Indo-Gangetic plains?
Yes, so there are what's called pH diagnostic ratios, which you can maybe look into reading more about. But basically, what they involve is look at the concentrations of specific pHs relative to each other. And depending on the result that you get of that ratio, the actual number, depending on the range, it informs the source of those pH emissions, whether it's petrogenic or pyrogenic, for example, and that can assist in identifying sources.
Thank you, Professor Forbes. Which additional classes are most policy relevant but currently undermeasured?
Well, I think that would vary actually probably from country to country. So I think in South Africa, we have more of an issue in terms of water pollutants and legal limits for those. And so maybe I can pivot a bit to discuss that. I didn't mention any of the water monitoring research that we do today. But certainly we are in the process of revising our South African national standard for drinking water and looking at increasing the ambit of which pollutants are included to include also some of the more what's called emerging chemical contaminants in water, particularly things like disinfection byproducts, including things like halomethanes and such like nitrosamines, which are known to also have human health impacts.
Thank you, Professor Forbes. Based on your research, to what extent, expressed as a percentage, can pollution levels be reduced?
Well, there always are trade-offs with these things. So, I mentioned now the example of the air quality offset by replacing a wood coal stove with a gas stove. But there are challenges to this because we have to consider also the long-term sustainability. We can say for now we have reduced the air emissions and as a result improved air quality. But if the community find it difficult to access the gas, the LPG gas in future, or if the cost becomes high compared to coal or scrap wood that is often burnt, then it could be that they revert to previous practices. So that's a challenge that we're going to have to consider. But in each particular situation, there are definitely trade-offs, and we need to always remember the bigger picture in terms of how we can improve in a sustainable way and that we don't incur other problems. And I think that's a general problem when we consider environmental issues. We have to consider the whole life cycle, the whole big picture, and not just focus on one area where we might be improving air quality in one area, but just transferring the problem to another. When we think even of energy production, we might think, we're using, people don't see the impacts of coal-fired power generation at their place of use that is happening somewhere else where they don't see it. So we need to always bear that bigger picture, more holistic manner in mind. But I think that one of the, as a person, if we're talking about the public, what the public could do, certainly not burning waste is one important step, as well as making sure that vehicles are maintained. In developing countries, there's still a relatively high incidence of vehicles that are emitting above regulatory limits. And if those could be curtailed, it would also definitely help in terms of emissions. But I think uncontrolled burning as well, along roadsides and so on, if people can be aware of these things and prevent them, that would be ideal.
Thank you, Professor Forbes. Were there measurable differences in indoor concentrations tied to stove use practices or ventilation behaviors?
Yeah, so we did note the ventilation behaviors because that, of course, can have a big impact in terms of what concentrations we determine indoors. And we wanted, as I said, to make sure that it was as most representative of usual conditions as possible. So we then requested that the residents set up their homes as they normally would when they used their combustion device. So if they were normally leaving the door open, they'd leave it open. If there were windows and they normally had them open, then they were conducted like that. And of course, that did also impact in terms of the different levels that of concentrations that we determined in the different homes as well.
Thank you, Professor Forbes. Do you anticipate any potential conflicts with the fruit and vegetable vendors if these products are used as feedstocks for biodiesel production?
I'm sure. Although the vendors, if we're talking vendors versus large suppliers, I think for the vendors it wouldn't really impact because they really smaller scale. So yeah, I don't think it would really have a big impact on them. But certainly in terms of food production, we need to bear in mind that we need to use land that is not used for food production if we're looking at planting crops for biodiesel, preferably, so that we don't impact negatively on our food security.
Thank you, Professor Forbes. Is it feasible to use a ceramic membrane coated with a thin polymeric film for the capture of greenhouse gases?
So it would depend what the polymeric film is and how efficiently it could capture greenhouse gases. I think I'd have to find out more about what specifically the person posing the question had in mind there. I couldn't just generically say at this point, unfortunately.
Okay. Thank you, Professor Forbes. And beyond total pH reductions, how did the biodiesel affect the pH profile?
Yeah, so it did change the pH profile. I had the one slide, sorry, I showed it rather briefly, but we do have a publication on this, so maybe I can refer the person asking the question to that, so you can get a clear idea of how the individual pH concentrations varied. But there was a change, yes.
Professor Forbes, one question is on did you do some measurements with personal exposure monitoring to evaluate actual dose and task level variability?
Yes, we did. So with our German collaborators, we actually utilized these denuders in a personal sampler in the mining environment. So the traps were protected by a plastic sleeve, which was then attached almost like a pen to the pockets of the miner. And they held the little pump on their belts. It has a clip for that. And we then determined personal exposure in that way.
Thank you, Professor Forbes. These were all the questions.
Thank you very much. Thank you for everybody's interest. I appreciate it.